Hello friends, I welcome you to my YouTube channel MacPM. So in today's video, we will continue our second lecture on operation research. So our today's subject is linear programming, and we will solve linear programming problem based on graphical method. The simplex method, we will use simplex method in our later videos. So in today's video, we will use the simple graphical method to maximize problem. So what are the limitations and conditions for graphical method? Let's read out. Generally, the method is used to solve the problem when it involves two variables. Let's see here. Z is 15x1 plus 10x2. If there was like 5x3, then this becomes equation in three variables, x1, x2, x3. So graphical method is not suitable for three variables, because if you are using three variables, then it will involve high imagination and planes. In two variables you have only x-axis and x1 axis, x2 axis, or x-axis, y-axis, and you have to deal with lines only. But in three variables you have to deal with planes, so it becomes highly complicated. So it is advised that graphical method should be used only for two variables. If you are having three variables, then you can use simplex method, which we will study later. Now, what are the other conditions? Solution of the problem lies in the first quadrant. Why? Suppose there is a company which this is coordinate x, this is coordinate y, and suppose these are the two restrictions. Then this is the feasible solution area. This cannot go into negative, because suppose you are making a profit, then you don't want to make profit in negative, you want to maximize your profit. So profit should be only positive, so we will consider only positive answers. So even if restrictions are not given, we will always consider x1 and x2 are greater than or equal to 0, or x or y are greater than or equal to 0. Why? Because profit, we don't want to make profit in negative areas. So even if you are minimizing the cost, then during minimization of the cost, you cannot take your cost in negative area, because you have to give salaries to employees, you have to run your machines, which will have some cost. So you cannot go into negative direction. So we will always consider x1 x2 greater than 0 or equal to 0, or xy, whichever you are taking as variables, these should be greater than or equal to 0. So this is our third condition. And the fourth condition is, this method provides a basis for understanding the other method of solution. So if you have already solved the graphical method, then you will feel better or good to solve other method like simplex method and other method. So let's continue with our first problem. Our first problem is, use the graphical method to solve the following linear programming problem. Maximize z is equal to 15x1 plus 10x2. So this z is given. This is called the objective function. So we'll write objective function z is equal to 15x1 plus 10x2. We have to minimize or maximize the objective function. So first of all, we will write objective functions, and these five things are limitation. 4x1 plus 6x2 is less than or equal to 650, and this and x1 x2 should be greater than or equal to 0, as we discussed. So these are constraints, and this is objective function. So how to solve these problems? First of all, these are inequalities. As you see, it is very difficult to deal inequalities. So for simplicity, we will use equal sign here. So we will write our constraints. 4x1 plus 6x2 is equal to 360. 3x1 plus 0x2 is equal to 180, or it is 0, so we can neglect it. And the third is 0x1, so 0x1 means 0 only. So third one is 5x2 is equal to 200, and fourth and fifth is x1 is equal to 0, x2 is equal to 0. Now you have to make a graph with x-axis and y-axis, but here variables are x1 and x2, so we will make x1 here, x2 here. Now we will draw the lines of this equation, which are constants. So first constant is 4x1 plus 6x2 is equal to 360. So we will find the extreme points. How to find that? See, 4x1 plus 6x2 is equal to 360. So what will be x1, where this line will touch the x-axis, x1 axis. When line will cross the x1 axis, then x2 should be 0, because at this point, if it is crossing this line at any point, then at this height x2 is 0, here 0 0 origin. So x1 will be 360. So x1 is 360 divided by 4, which is 90. So our x1 is 90, we can see, and x2 we have already considered 0. Suppose this is 10, 20, 30, 40, 50, 60, 70, 80, 90. So suppose this is point A, 0 0 is point A. If we have more value, then we can extend this line, but for now this is point B, suppose, and it is 90 0. 90 we have calculated here, x1, and x2 we have seen 0. Then at this point where line will cross this axis, here x1 will become 0. So 4x1 plus 6x2 is equal to 360. So x1 is 0 at this axis, so x2 is 360 divided by 6, which is 60. Now here also we will draw the lines 10, 20, 30, 40, 50, 60, 70. So this line is crossing here at 60, 0, 60. Suppose this is A, B, this is C, here it is 0, 60. So this is line is going from 0, 60 to 90, 0. This line is 4x1 plus 6x2 is 360. Similarly, our second constraint is 3x1 plus 0x2 is equal to 180. 3x1 plus 0x2 is equal to 180. So 3x1 is equal to 180. x1 is 180 divided by 3 is equal to 60. So our second line is x1 is equal to 60. So where is x1 is equal to 60? Here see x1 axis, and it is equal to 60. So this is a vertical line. At this line x1 will be always 60. Okay. Now our third is 5x2. 5x2 is equal to 200. 5x2 is equal to 200. So x2 is 200 divided by 5, which is equal to 40. So our third line is x2 is equal to 40. You can see that there will be horizontal line. At this line x2 will be always 40, and this one was our x1 is equal to 60, and x1 is equal to 0 is this line. X1 is equal to 0 is x2 line, x2 axis, and x2 is equal to 0 is this line, which is on x1 axis. So this is our area which we have formed from these constants. Now we will see the inequalities. First one is 4x1 plus 6x2 is less than or equal to 360. So less than means left side of this line. If it was greater than, then it will be right side, but it is less than, so it will be less than in left side. Why? Because if you take the values greater than x1 is equal to 19 and x2 is equal to 60, then it will be outside of this line and it will be greater than 360. Suppose you are taking x1 is equal to 100 and x2 is equal to 100, then our equation will become 400 plus 600 is equal to 1000, which is greater than 360. So it is now satisfying the inequality. So it is in left side of this line. Our second is 3x1 is less than or equal to 180. So x1 is equal to less than 160. So it will be also in this side. Okay. And our third inequality is 5x2 is less than or equal to 200. So x2 is equal to less than or equal to 40. So it will be also in this direction, downward direction, because only lower values than 40 will satisfy this equation. Now our fourth inequality is a constant is x1 is greater than 0. So x1 is greater than 0 and x2 are greater than 0 will be, if it was less than, then it will be downward but in this direction. And x2 is greater than 0. This is x2 is greater than 0, x1 is greater than 0. So you can see that we have found this area which is common in all the constraints, this area. Okay. Now suppose this was point A, this was point B, this is point C, this is point D, this is point E, this is point F. Okay. So how to maximize the profit? We have to calculate at the extreme points. What are the extreme points? This is a shape we have shaded. So in this method we have to find the value of objective function at extreme points. So what are the extreme points? We will make a table. Here we will write extreme points. Okay, then coordinates, then objective function. What is our objective function? Z is equal to, you can say from here, Z is equal to 15x1 plus 10x2. Okay, what are our points? This is A, this is C. What are the extreme points of this shape or corners? You can see A, C, D, then E, then F. What are the coordinates? You can see A has 0 0, it is origin, so it has 0 0 coordinates. At C coordinate is 60 0, because at x1 axis this is 60 and x2 axis is 0. At point D, what are the coordinates? So we have not calculated the coordinates at point D and point E, so we will calculate. You can see that at point D, the line 4x plus 6x2 is equal to 360 and the line x1 is equal to 60 are intersecting with each other. So we will write these two. 4x1 plus 6x2 is equal to 360 and our second line is x1 is equal to 60. So we will solve these two equations. So we will put x1 is equal to 60 in this equation, so it will be 4 into 60 plus 6x2 is equal to 360. So 240 plus 6x2 is equal to 360. 6x2 is 120, so x2 is 120 divided by 6, which is equal to 20. So this coordinate is 20. x2 is 20 and x1 we already know 60, so we will write 60 and 20. Point E, at point E, similarly you can see which lines are intersecting each other. So this is line 4x1 plus 6x2 is equal to 360, 4x1 plus 6x2 is equal to 360, and the line is x2 is equal to 40. These two lines are intersecting, so we'll solve these two equations. So we'll put x2 is equal to 40 here. 4x1 plus 6 into 40 is equal to 360. So we will have 4x1 plus 240 is equal to 360. So 4x1 is equal to 360 minus 240 is equal to 120. So x1 is 120 divided by 4, which is 30. So our coordinates will be 30, and x1 is 30, x2 is 40. So it will be 30 and 40. At point F, you can see that coordinate x2 is 40, x1 is 0 here. So it will become 0, 40. Now we will put these coordinates in this objective function so that we can get the value of objective function. So here will be z is equal to 15 into 0 plus 10 into 0 is equal to 0. Here we will get z is equal to 15 into 60 plus 10 into x2 is 0 is equal to 15 into 60 is 900. At point D, we will get z is equal to 15 into 60 plus 10 into 20, which is equal to 900 plus 200, which is equal to 1100. At this point E, we will get z is equal to 15 into 30 plus 10 into 40. So we will get 450 plus 400, which is equal to 850. At point F, we will get z is equal to 15 into 0 plus 10 into 40. We will get 400. So you have obtained the values of z at various locations at A, C, D, E, and F. So you can see that which value is maximum. So you can see that z is maximum at 1100 at point D. From here you can see that z is maximum at point D. So at this point we are getting the maximum value of z. So z is equal to 1100 at point D, which is equal to 60 into 20. So what does this mean? It means that if you are producing, there are two products A and B, x1 and x2. And these are the various constraints given. Sorry. Then if you are producing suppose you are producing 0 quantities of products x1 and x2, then you are getting profit 0. You are producing 60 quantities of x1 and 0 quantities of x2, so you are getting profit of 900. You are producing 60 quantity of product x1 and 20 quantity of product x2, then you are getting a profit of 1100, and similarly at 50 and 400. So this solution means that if you are producing the product 60 and 20, products x1 is equal to 60 and x2 is equal to 20, then you are getting the maximum profit of 1100. So this is our maximization problem. You have maximized your profit. Now here you can see that you have found a value of x1 and x2 here. You can do another thing like 4x1 plus 6x2 is equal to 360. So you can divide it by 360 plus 6x2 divided by 360 is equal to 1, or x1 by 90 plus x2 by 60 is equal to 1. This is equation of the line, this line. So you can say that we have a line equation of line is x is equal to a plus y is equal to b is equal to 1. If you can compare, then a is equal to 90 and b is equal to 60. So you can get the intercepts at x1 axis and x2 axis, which is equal to 90 and 60. Here see 90 and here 60. So you can either calculate by putting under value 0 and getting, suppose you are putting x2 is equal to 0, then you will get x1, or you can convert the equation in this form and directly put the values here. You will get the equation of the line and various intercepts. So I hope you understood this problem. If you have any doubt, then please ask in the comment section, and thanks for watching my video.